Well, hello and welcome to another DevNation Live Tech Talk. I can learn to say the words. You think I say them too often. DevNation Live Tech Talk. We're going to have a lot of fun today. We're going to be talking about kubelets and a deep dive kind of Kubernetes topic. We have Rob here, and let me see if I can get the name right. Szumski. Pretty close.
Yes.
Szumski. I'll work on it. I'll practice that. But it's actually going to be a lot of fun because this is a kind of topic that we love having on the Tech Talk, where we can actually show you some really interesting things about a specific aspect of Kubernetes. As you've seen in many of our presentations, we talk a lot about Kubernetes, we talk about OpenShift, we talk about Knative, we talk about Istio, we talk about Kafka, and all the operators and everything else you can do with Kubernetes. And of course, we talk a lot about Java and Quarkus and things that you can do within that context. Just a moment ago, we talked to you about Camel K, and how it's been optimized for Knative on top of Kubernetes. Now we're going to talk about kubelets and what you can do when there are no masters, no supervisor nodes. So I think that's going to be a lot of fun. As always, stage your questions into the chat. We'll look for them there, and I'll relay them on to Rob when the time is right. But otherwise, we're going to let him get going here. Hello from Chennai, all right? I see Edward here from the Netherlands, too. So hello from India, hello from the Netherlands. Thank you so much for that. At this point, let me turn it over to Rob. Rob, let's go.
Thanks for coming. Get my presentation started here. So yes, we are going to talk about a kubelet with no Kubernetes control plane. Pretty exciting. I think this is something I've been messing around with in my spare time. So while right now I am an OpenShift product manager, I deal with a lot of the operator-related concepts inside of OpenShift. We're not going to talk about that today. We're not going to talk about OpenShift at all. We're just going to talk about Kube. And my experience with Kube comes from being an early employee at CoreOS. And I've basically been playing with containers and Kubernetes since they existed. And this journey that I'm going to talk about today and this project that I've implemented kind of mirrors my experience with Kube in the early days before we had all of these tools like kubeadm. And so you were orchestrating things a little bit more manually, and there's some really cool stuff you can do when you do that. I'll dig into a little bit more about the project that I'm working on, but just to give you an overview, I'm planning out an edge deployment for my shop in the shed in my backyard. I've got some industrial equipment that I want to operate and some cameras and some cool things like that. And of course, I use Kube, so I want to use Kube to do that. And so we're going to explore how I set this up, but then just talk about edge deployments in general and not requiring a Kube control plane. So stick around. It's going to be pretty interesting. But before we get there, I kind of want to build this up. And so first, we got to talk about, where did we start from? How did we get here? And so in the early days of Kube, say 2013, 2014, we kind of had these three technologies, and they were all fairly separate. So we had etcd for coordination. This is a distributed data store that does a really good job with consensus. So it's good for coordinating machines when you need to know that, if you're doing a leader election, that you're only going to have one leader. And so there's special semantics inside of the etcd database that helps you do that. So this is a core part of building a distributed system. Then we had Docker, for containment. You can package up all your dependencies inside of a container and ship it around, and it's really easy to start that. The works on my machine, works on every machine kind of thing. And that was really perfect. That's a really, really crucial part to just running software today. And then we had an init system. In this case, I'm very familiar with systemd. For doing the life cycle of that application, streaming logs back from it, starting, stopping it, restarting it when it fails, all the good stuff that the init system does. But the init system actually does a ton for you, just even related to C groups management and that kind of thing, which we'll dig into a little bit more. And so, of course, things have changed, but I thought it might be fun to take a look back. I was looking at in the early days of CoreOS, some of my first contributions to the community, and what it was this documentation page. And I thought it was just kind of a cool look at where we came, so I'm going to jump over really quick. So this is the doc on GitHub. You can see this commit was in September of 2013. We're talking about Docker version 0.5 here. I think that's like 2 versioning schemes ago for Docker. When we're talking about CoreOS, remember this is people's first interaction with all these technologies. This stuff was so new. Here's the etcd section. It's like 3 paragraphs long, and it's just talking about using curl to set a value and then get it back. This is like the kind of key part of running a distributed system. 2 machines need to exchange messages about something they both care about. But that was it. If you wanted to know more, you had to jump to another place on GitHub, which is kind of funny. And then you move to Docker. We just have two commands documented here. We're just going to run Ubuntu and echo out hello world. And then if that's not cool enough for you, you can actually go get an interactive TTY on this and jump into a bash shell. And that was the extent of our Docker docs, which is also funny. And then the last part, systemd. This one is a little bit more beefy because systemd in those days was super new to everybody. I wrote a ton of docs around systemd because we kind of chose systemd before Red Hat and all the major distros had even gone down that path. So unit files and things like that were all different. And I think it's interesting to look back, folks, running Docker via just a command line run in a systemd unit, and you're just doing the same Docker commands that you're doing. It seemed super cool and advanced at the time, but it's actually like, I don't know, kind of crazy that this was the cutting edge. So I'm glad that we've gotten way further. So let's go talk about, where are we today in 2020? And so where we are is we still have all these same tools, but they've moved into Kubernetes as kind of this standard that's one. So we're still using etcd, which is really cool, but we're using it via Kubernetes. So you don't actually really know that it's there. I think the actual only hint you as a Kubernetes end user know about etcd is if you do kubectl and get a pod in the YAML view, you'll see there's this resource version. I believe that's actually the etcd index of the object that's stored. Etcd is a write-ahead log, so the index is always increasing. I think that's the only indication you're using etcd. And then we use a container runtime via an interface in Kubernetes, so it's not just Docker directly, but we're using the container runtime interface, CRI. And then we've got kube, instead of interacting with an init system, kube does our lifecycle management, streams back logs. So let's talk about all these in a little bit more detail, only because it's interesting. We got to talk about the architecture to strip it back to get to our kubelet without the control plane. So when you think about it, when you're using Kubernetes, you've got this workload YAML, and that's all your pods and deployments and stateful sets and things that describe your application. You submit it to kube, and it makes stuff run, right? So we're using etcd under the hood to store everything. And we've got this control plane that's doing some stuff on our behalf. And the core of kube, as you know, is just creating pods. Pods are like kind of the lowest level deployment that you have. So when you've got something that's stateless and you say, I submit that and say, I want you to start 30 of these things, the controller manager, piece of software, makes 30 pods. And they're not running anywhere yet. They're just pods that exist in etcd once again. Then the scheduler goes and says, hey, I need nodes that have the correct number of resources or other requirements to run these pods. It matches them up together, and boom, a node checks in and says, which pods do you have for me? Here's 2 of them, like you can see on the right-hand side. So that's kube in a nutshell. That's what you get out of having the control plane, is you get all these higher-level primitives. So like a stateful set, for example, is matching up a pod with a stateful disk so that you can run something like a database. So there's some semantics there for, hey, find me a node that can accept this disk, schedule the pod there, and then mount that disk into the pod. Relatively simple, but there's a lot of logic there that you're getting out of it. So let's look at a node a little bit more in detail. So this node is assigned a pod by the scheduler, and then there's some stuff on this node that does some stuff for us. There's the kubelet, which is what we're going to end up talking about today. That's the Kubernetes agent that is doing things, and that's interacting with the container runtime to run stuff, Docker or CRIO in Red Hat technologies. And then the operating system, it's orchestrating C groups, and it's looking at the resources on the node and interacting with the kernel and things like that. And so it starts that, and on the right-hand side here, you can see what a pod spec looks like. And so, the port mappings are going to be done by the container runtime. The resource limits are going to be done between the kubelet and the operating system. Volume mounting is going to be done by the container runtime into places on disk or elsewhere. So this is kind of how it all works. And then, of course, the node reports back, to get streaming logs and the pod status and the node status and all that. So that's kind of how Kubernetes breaks down. So let's take a step back really quick and just talk about the end state that I want to get to. So I have my shop that I was talking about, and I've got this piece of industrial equipment. It's a CNC, which is a computer-controlled router, which you can see running on the top right there. So I want to run this thing. Of course, there's all this open source software for running and accepting jobs, which you can see on the bottom. And I want to have that running in containers, but I want to use kube because I think kube is a really great piece of technology for modeling the life cycle of an application. And I've also got some other apps. I've got, this camera that's going to be recording these time lapses. I want to do DVRs and automatically transcode that and speed it up. Of course, I want to access all this remotely, so I've got a web server, I've got a proxy to secure all the access to it. And so all this software needs to be updated, change its config, needs to be restarted if it fails. And what does that really well is Kubernetes. But I just got a single machine. I don't really need an entire control plane. And so that's kind of what the rest of this talk is about, is what you can do without a control plane, but still use kube, still use your pod YAMLs. And what this really is a stand-in for is an edge deployment. And an edge is kind of, if you look at this spectrum, on the right-hand side, you've got like a big data center that like a cloud provider would run. And then moving all the way over to the left, you're getting into machines that are either single machines sitting in a closet somewhere. It might be on like a telephone pole, might be on a cell tower, might be running in a self-driving car, or sensors that are running on aircraft or stuff like that. These single machines that need to tie into other things maybe, but they're not part of a cluster. So that's what we're going to talk about today. So everything, all this technology that I'm talking about from my shop, you can imagine being all kinds of other things. Here's a bunch of great examples: robots in factories, even every cable modem that's out there, every Linksys router really is just a Linux machine with a firewall. Check-in counters at the airport. Hopefully you're not flying right now due to COVID. And then all these sensors that are out and about on water towers and telephone poles and stuff like that. So keep that in mind while we frame this together. And so if we go look back at our control plane, do you actually really need a control plane for these use cases? I've got my 5-7 pieces of software, and they need to be updated, and it's just really a node, though, at the end of the day. So the question is, can you get rid of all that but still get some of the goodness of kube versus manually orchestrating Docker like I showed in that doc, where you're running systemd units manually, or Docker Compose files and things like that? Because as we talked about, Kubernetes has won. These APIs like pods and deployments and the way that those are managed have kind of won the ecosystem. And so we want to use all that tooling, all the docs, all the knowledge that everybody is sharing around that. So let's dig into how you do this. So this is called the standalone kubelet. And what we're going to do is basically take the architecture that we described on that node and just fence it off. There's not going to be any talking to the internet if you don't need to. This works fully disconnected. It's just a Linux machine running at the end of the day. So there's no control plane. And we're going to use something called the static manifest feature. This is also called static pods, if you've seen that talked about in the kube ecosystem. And that basically is you, the human, being the Kubernetes scheduler at the end of the day, instead of having a piece of software do it. And the cool thing about this is it's fully compatible with automatic provisioning. So picture, you need to prep a node in your computing environment like you do. Some people might install stuff manually via an ISO. You might make golden VM images. You might use something a little bit more advanced like Cloud Init or Ignition, which is a pretty bleeding edge way to do immutable infrastructure, which we can talk about. And so it's really cool if you're going to stamp out not just one or two of these, but maybe 1,000 of them, or 1,000,000 of them on every cell phone tower, for example. And it's more powerful when you pair it with a self-managing operating system. So this is ground that CoreOS broke, and we're continuing at Red Hat, is can I have an operating system that knows how to manage itself? So we built some of this technology into OpenShift, which I'm sure you've heard of on this channel. And of course, you're using some of the kube bits still. We've got the kubelet in place. We're using the container runtime and container network interfaces like you would per normal. And so you're using a lot of the kube ecosystem still. So let's take a look at this standalone kubelet. If you were going to go set one of these up, what do? So here I just catted out my kubelet service from my box. And as you can see, it's just running a kubelet. And really all it is a collection of environment variables, which is kind of a cool way to get config into this. So user bin kubelet is running the kubelet with a bunch of standard flags. And then we've got our kubelet arguments, which we're sourcing from this environment file. So on the right-hand side, you can see a bunch of interfaces. You'll notice here that there's nothing about where's my API server, where's the control plane, because we're not talking to a control plane. But what we do need to talk to is our container runtime. So you can see the socket for CRIO. That stands for CRIO. So CRI is the interface for the runtime, and that is a container runtime that's really cool because it's only designed to run with Kubernetes. It's not a full-fledged thing. It only runs kube, which is cool. Keeps it lean and mean. And then we've got this pod manifest path. This is just a directory on disk where if you place a YAML file that is a valid pod, this kubelet will start it up and keep it running and do all the regular stuff that kube does, just like you would submitted it via kubectl and it went through the API. So that's what we're going to use to power this entire deployment. So, we're talking about losing our control plane here. So, like, clearly some stuff is not going to work, right? We're eliminating a ton of the complexity of running the entire etcd database and networking between machines. So let's talk through what works and what doesn't. So the powerful part of this is all the stuff that does work. So we've got pods as a way to start multiple containers and have multiple pieces of software that are deployed side by side, doing volume mounts between those different containers, setting security contexts, resource limits, protecting the node from the workloads. All the stuff about networking, so you get the port redirection and indirection that people love in Kube. You get node ports, of course, if you need to listen for things on the outside world. You get all the debugging via log streaming. You can attach to the containers that are in the pod. You can exec commands in them, all the stuff that you normally do. And then you got some life cycles features like restarting the pods on failure, all the stuff that Kube does to keep you from, waking up at 2 o'clock in the morning and having to restart things and SSH in. So all that stuff is great and works just like it would. You just take a pod YAML and use it. But what doesn't work is stuff that makes things that run across multiple nodes or uses that control plane. So if you think about a daemon set, a replica set, deployments, those all stamp out copies of pods. Whereas here, we're being the human API server, we're stamping out the pods instead of those pieces. And then, of course, we're only on a single machine, so things like services and ingress, network policy aren't as applicable here, and so those don't work and aren't needed. And then there's no authentication. We're not even listening on an API. So there are no events. There's no RBAC. There's no authentication needed. So think about all the stuff that you don't have to manage now that you typically would in a Kube environment, which is pretty cool. And then PVs and PVCs, direct host mapping of volumes is actually the most easy thing to do here. And because these pods aren't moving around between nodes, it's not a big deal. And then lastly, it pains me, but you don't get operators and the custom controllers, admission controllers, all that really advanced stuff because there's no control plane, but also you don't need that advanced stuff. You're just running, this single node. So now that we've covered that, this is going to change a little bit of our workflow. And so I wanted to talk about that for a second. So the changes we need to make, obviously, in my shop example, I want to have an interface that's exposed on the internet, so I can get at this remotely. So we need to ingest some traffic, and so you do have to run your own Nginx or whatever your piece of technology is for doing ingress. I'm used to running an Nginx ingress anyways on a node port on my Kube clusters. So basically, I'm just doing that, and instead of having it respond to ingress events, I'm just configuring Nginx directly. So no real change there for me. If your Kube provider has an ingress controller that kind of comes default, this might be a little bit of a learning step for you, but I think it's actually really cool to understand how this works underneath the hood anyways. So I've got that listening on 80 and 443, as you'd expect. And then volumes. So like I said, instead of persisting to a PV, because we don't have those, we're just going to write directly to the host storage. This is nothing crazy. You just use the volume mapping stuff that's in the pod. Then the biggest one is going to be, since kubectl talks to an API server, we're not going to have a kubectl. But what we do have is cryctl, that's the container runtime interface control. And that can stream logs exactly like you would do with kubelet logs-f. There's a bunch of other things. You can do ps to list all the containers that are running and that kind of stuff. So let's see what that looks like. And remember, we're just listening for a directory and putting YAMLs in it. So the coolest part of this is your deployment tool. You can use SCP. So here, I'm just taking this pod YAML and throwing it on a remote box. You can imagine doing this times 1,000 remote boxes if you wanted to. Or we're going to talk about some more advanced stuff you can do. You could also just SSH onto this box and open up Vim and start writing a pod and save it. And the kubelet has a interval that it's checking for pods, and it'll start it in 10 seconds or whatever, and do all the stuff that Kube does, which is pretty cool. If you want to list all your containers that are running, in the middle here, here's my cryctl PS, and so these are the 4 pods that I have running. You can see I've got my DNC software, I've got my proxy for doing authentication, I've got the Nginx web server, and I've got my transcoding job, which is reading my cameras and transcoding that and saving it to disk. And then if I want to look at logs for one of these things, it works. I mentioned we're going to use cryctl instead of kube control, but it works the exact same. You give it a name and you get logs back. Here we're looking at the logs from my proxy. So you can see that somebody tried to authenticate here and got a refresh token, and that's kind of how it works. So it feels very similar in a environment to a true kube cluster, but we're greatly reducing our burden for what we have to run because there's no etcd and all that kind of stuff. And the key part, if you're going to take away anything from this, is that the Kubernetes pod is the API, and that's the power of this. And if you think about it, here's a bunch of things that you're going to get. But if you were just going to do this without kube, you would have to invent all these semantics. You'd have to invent all the tooling that helps here, versus you can just reuse what the community is already building. So if you imagine that you're somebody at Linksys and you're going to write some remote management and deployment software for updating all the routers, you're doing that all custom. Hopefully all your crypto is good, and hopefully your operational practices are awesome. But here, I'm not inventing a new API. I'm not inventing any authentication mechanisms or any of that. I'm just using stuff that we already have from the kube community. So some really cool things that, probably even like those Linksys routers don't have, which is like liveness and readiness probes for their software when they're updating them. Obviously those things reboot and they don't do it in a smooth process. And so you can gain a bunch of really cool stuff even though you're not using the rest of kube. Security context constraints and all the resource limits and all the stuff that kind of protects you from yourself sometimes when running this. And then let's talk about scaling this. So my deployment here is very manual. I just installed a Fedora CoreOS build, Fedora Core 31, and just manually configured some things. So my container networking config and that type of thing. But what you actually want to do is probably do this hundreds or thousands of times. If you're, deploying this to every self-driving car in a fleet, for example, you need to have a repeatable process. And so on the small scale, if you look at it, this node is really taking some machine configuration, and then you just need a pile of pod YAMLs. And so if you could make a golden image of these things and start stamping them out, or do it manually, is not as ideal. But what you probably want to do is do this with a technology that does the machine configuration for you. And there's a lot of tools out there for doing this. If you happen to like Chef and Puppet, I think the world is kind of moving away from that stuff into newer technologies. I mentioned Ignition. The cool thing about Ignition for operating systems that support it is that it runs before the actual Linux operating system is up. So you can configure things that normally would not be able to be configured. Like you could do network management, you could RAID disks and do other things before even like Fedora boots or before your RHEL box boots, which is really cool and great for doing immutable infrastructure. What you can do is actually source that file from a remote location. So picture getting it from the cloud storage bucket. And if you need to change some of the config on all these nodes, you update that cloud storage bucket, and then all these devices, whenever they either reboot or re-manage, they get that new config. Then you can do the same thing for getting your pod YAMLs. At the end of the day, you're going to have these coming out of some sort of CI system, and they need to go somewhere. And a simple deployment process for this could just be a systemd timer that, every 5 minutes or every hour or whatever, every night at midnight, goes and just curls down a bunch of pods and sticks them in a directory. This doesn't have to be complicated, and this system could scale to hundreds of thousands and millions of devices if you wanted to, which is really, really cool. And that's kind of the next frontier for kube, is running in these types of environments. But picture all the resources you're saving by not running all the other related infrastructure, the entire control plane, an entire etcd database that stores stuff in RAM, so you're eating up RAM there, and then all the complexity of actually running that stuff. So I think this is really cool. And if you've some people are taking some stabs at this. If you've seen the Chick-fil-A thing from a few years ago where they're running some small kube clusters in all of their stores to do certain things. But we're going to see a lot more of this in the future for like 5G rollouts of folks running kube in really cool places. And I know we've got some RHEL running on satellites and things like that. Hopefully we'll get a kube cluster up in space sometime soon. So if you want to try this out, I will admit it's kind of bleeding edge, and I had to cobble a bunch together. So I got this gist. This is from a coworker of mine. We've been trying this out together. So take a look at it. This will walk you through getting a kubelet and doing all of the config of the machine itself, and a little bit of testing it out. Once again, that's with Fedora Core 31. And then this is based on a really old tutorial that Kelsey Hightower wrote around using Container Linux to do this with a standalone kubelet. Note that Container Linux did just recently EOL as part of its lifecycle. So I've been tweeting at Kelsey to get this updated to a Fedora Core or Fedora Core OS, even better. Those are two different OSs in the future. So hopefully once I figure all this stuff out in the ignition files that I was talking about earlier, I'd love to get that updated. I'm running into one or two little bugs in the ignition files, or else I would share it with you. But I want to leave you with, like, this is the future solution that I want to describe, which is Ignition takes these references to a remote file. I call this a stub. And so you can imagine you just boot a machine and you give it just this first text box up here, just a really simple file that says, hey, go get this other file. Here's how to verify it. And you can host this on the cloud, as you can see I'm doing. And all you would do is, pass that to your cloud provider if you're using a cloud, or you pass it to an installer if you're installing on bare metal, or if you've got a way to boot machines via Pixie or iPixie. All of this works to run hundreds of thousands of these if you're running a factory, for example, and you've got all those robot arms making cars and stuff like that. So I think it's really cool. Once I get this working, I would love to blog about it. But if you do play around with this, please tweet at me. I would love to talk to you about it and make this kind of a standard in the Kube community. If you do want to reuse all of these APIs, like I said, the pod API is really powerful, but you don't want to run the whole control plane. And I think that's all I got. So I would love to take any questions. And if folks are interested, we can go poke around on the box that I have running too. And I can show you some of the other config. I know this is a little light on very, very concrete details.
And there's one question right from the gate. That's related to, is there an Ansible module that helps you do this installation and management of, let's say, try-CTL, as an example? And then kind of came back and said, well, maybe a more modern way of Ignition. So could you talk to the Ansible versus Ignition for a moment?
Yeah, so they both fulfill kind of the same need, which is you want to do some automation around something. The really powerful thing, like I said about Ignition, is you pass it like before you have even booted a box. So like you can do some configuration before this thing even has an IP address or anything like that. Whereas Ansible would happen a little bit later in the life cycle. No reason that you couldn't use both. I do not have, like I said, I don't have Ignition or Ansible for you, unfortunately, right now. But both would be easily applicable. In that gist, you can see that you're not doing that much to the node. You're basically bringing it up, installing Docker, installing, Cryo, installing the kubelet, and then writing some config for like the CNI, like the networking interface. And you're not even doing much of that. You're basically giving it some loopback addresses and things like that. And that's really it. So it is pretty simple, and it wouldn't be that hard to write Ansible to do this.
Okay. And you also mentioned something called Fedora Core, as if it was something different from Fedora Core OS. Are those two different things?
I believe they are, yes. I think Fedora Core is a more stripped down version of the regular Fedora that you're used to. In this case, I used 31. And then Fedora Core OS, which is confusingly named, I will admit, is the successor to Core OS Container Linux. And that is what we use inside of OpenShift 4. And that is more of an immutable setup for an infrastructure versus Fedora Core, which is just more, it's like stripped down but not immutable, if that makes sense. And so when you pair Fedora Core OS plus Ignition, you get these kind of easily self-managing installs of a kube node, whether you have a control plane or not.
And I can't even find a Fedora Core download. So by default, it keeps trying to send you Core OS. Workstation server Core OS, but I don't know about that.
Yeah, I found one. I think it's in that gist. Go look it up. I think it is in the top of it. But anyways, you can find it. I think there's a web page that has a bunch of them. Oh, it's not on here, actually. Anyways.
And the other question that came in was, can you give me more examples about Ignition? And actually, I'm kind of curious to know, what if I wanted to learn Ignition from the very get-go? Hello, world. Where would I go to get started learning about Ignition?
Yeah, well, I'll just, the easiest way is to pull up the docs, and I happen to have written a lot of these docs, and so I can talk you through them here. This is the old CoreOS website. There are Ignition docs on the for the new flavor of Ignition that is inside of Fedora CoreOS. I just know this one is easy. Here's some information about Ignition. The cool thing are the examples, though, which are general examples. Here we go. Okay. So the first thing to note is it's JSON. This was a big thing for us. If you've used Cloud Init, which is YAML, linting YAML is actually notoriously hard to do because there's not an actual, like there is a spec, but it's not everyone is in the same consensus of what the different specs for YAML are. Kube has picked a specific version of that spec. Some of the cloud providers picked other ones. So we kind of sidestep that whole thing. So it's JSON. There's also some tools that you can use to help you, convert this. I think there's a Fedora CLI that helps you do this. So here's a good example of just like starting a service. So I mentioned that, there's a systemd unit out there. And so what this is going to do is you're providing it as well as the name and to go enable it, so to map it into the run.d directory or whatever. It's been a while since I've done this. But anyways, that'll set it up for this multi-user target. But some cool things you can do are, if you do need to create files on disk, here's go put this file data at this path. You can imagine using this for public keys and things like that you want to do. You can also fetch stuff remotely. I mentioned that you can even fetch the entire contents of the file remotely, of the Ignition file itself. Here's, creating some RAID volumes. You can see how kind of explicit this is on what you're doing, which is really, really nice. So if you imagine that you want to go set up 1,000, Dell boxes the exact same way in a data center, you could do it with Ignition very, very easily. And this is just going to boot, and it's either going to work or it's going to not. That's what keeps you immutable. There's no place for this to go wrong, like in a Chef or Puppet run or using some Ansible config. If one of those jobs failed halfway through, you would be left in this inconsistent state. Whereas here, you're doing this before all of Linux even boots. This happens in the init.rd, which is like the RAM disk. That's like the really, really cool part of it.
That's very cool. And so there's another question from Alberto related to, can you explain how would you update your operating system when the kubelet is running this way and it's running through Ignition? What happens if you have a OS level update?
Yeah, so there's not any magic there. You're gonna, because this is a single node, you're gonna take some downtime to do that. And that either, you can schedule that to be at a time using any tools that you want. If you wanted to go poke at these with like a Fabric script or an Ansible script, or just have a systemd timer that's gonna, update something in reboot or whatever. And so if you are sharing something or collecting some sort of data or whatever you're doing with this application, it is going to go down while it reboots. That's just kind of the nature of what you've signed yourself up for by using a single node. And so what we do instead of in OpenShift with CoreOS is we pick those nodes to happen one at a time and go reboot them. You could also write a piece of software to do that too, if you did want to do it. But then you're getting into like reinventing kube territory, which is maybe okay for your use case, but you just need to be aware of that too.
Right. And then one last question. So James was like, what about K3S? In other words, can you kind of compare and contrast what K3S might give you versus something like this?
Yeah, so I think they're very similar, other than K3S is actually stripped down kube. So but it has a control plane. So it's kind of, if you imagine there's full kube, there's stripped down kube, and then this is like no control plane. So I think this is even more minimal. I will admit that I don't have a ton of hands-on knowledge of K3S, but I do, am very aware of it. And so I think that's the main difference. There is an etcd database, or actually I think they stripped it out for Postgres in K3S. So you still are running all of those components. And so you are going to get all the other stuff that I'm talking about that you can't use. You are actually going to get that with K3S, which is nice. I think there's still some caveats there, but you could use a replica set to stamp out 2 of these on a single node, for example. But in my example, you would just make 2 pods, make 2 YAML files, and you get the same thing.
Okay, very cool. Well, we're out of time, and I thank you for all those questions. That was certainly great for the folks that are here. And Rob, this was totally eye-opening from my standpoint. I had never thought of the use case like this. So it was actually a great session. I really enjoyed it. It was a nice deep dive into some aspects of Kubernetes that people normally don't think about, certainly not me. So fantastic stuff.
Awesome. Yeah, like I said, if folks check it out, please tweet at me. I'd love to talk more about this and make this a more standard thing.
Absolutely. And I did put Rob's Twitter address on the chat, so you guys have that there. Feel free to follow him. Check him out there. And you guys all know how to find me via email if you guys need anything else in the future. Rob, thank you so much for your time today. It was absolutely great. Fantastic stuff.
Thanks. It was fun.
All right, well, we're out of here. You guys have a great day, great weekend, and we'll see you for the next master courses starting on Monday.